Good afternoon, everyone. My name is Young, and I am the instructor for Introduction to Software Engineer for the fall of 2024 at Kennesaw State University. I'm just doing this recording, just hopefully give you guys some information and background into the field so that you guys have a better understanding of what it is that we do. Before we begin, just very quickly, for some of you that don't know me already, I have been teaching at Kennesaw for about 5 to 6 years now, and I'm also working in the field as a software engineer, manager now. But don't let the title dictate what you can and cannot do. So really, for intro to software engineer, what is really important, right? Before that, if you guys don't have any join diagram already, you can use jaw.io. It's completely free and it is behave just like Lucid.io. Lucid Chart, if you have heard. But this tool is free and it's very good, so I would recommend to use it. With software engineers, the first thing that everyone should understand is we are problem solver. Okay? And what do I mean by that? What I mean by that is the first connotation that usually would come to mind as a software engineer is you we do coding, we do a lot of coding, but that's not true. Before you can even do any coding, you need to know what your requirement is. In order to really know your requirement, you have to know who your customer is. Different customers will give you different features that they want to have. And so, in order to truly identify what the customer need, you have to be able to know techniques that you can use to extract that exact need from them, right? But everybody comes to you with a need or a problem, and they expect us to solve that problem or that need for them. The end product is usually something that they can use to either facilitate them in their daily process or to help them monetize in something that can generate revenue for them. And so software engineers is problem solver. We know what the customer wants. Now how are we going to help turning what it is that they want into something concrete that they can use? Okay. With that said, really in software engineer, there are some phases. The first one is on-way requirement, right? Requirement has a couple of things that are important. First of all, who is the customers? You have to be able to identify the true customers, right? Who it is that asking you to build a system, what it is that they want, how do they want it. After you know who is the customer, know what is the problem they're facing. Okay? From knowing the problem they're facing, you basically would be able to know, okay, what it is that I need to build to help them. And sometimes from knowing the problem they're facing, you will actually be able to really advise them on what should be done. After you know the problem they're facing, right? The next thing is what are all the features or behaviors customer want for their system, right? These things is usually in the system requirement. Requirement really is who it is that I need to talk to. What is the problem they facing? What it is that they need my help to solve? And to associate all of those things together, that is the requirement. Also known as the software requirement specification or SRS. SRS, right? So the requirement is that is like a contract between you and the customer. Whatever is not on the requirement, they cannot expect to see it in the final system. right? But what is on the requirement document? And if you both, the customer and yourself, agree to it, then those would be the the final behaviors or the system that the customer expects to receive when you go and buy a house. You basically tell your builder how you want your house to look, the kind of color you want your house to have. So all of those things would be requirement. Requirement can be broken out into two different things. The first one is known as the non-functional requirement, and the second one is known as the functional requirement. Those two are very different, right? So first of all, to have a requirement, you need to know once again those three things above here. Once you get to thing number three, which is the feature and behavior that the system should have, that should be able to help you to identify the functional and the non-functional requirement. So functional and non-functional contribute to make a complete requirement document. What are functional requirements? Functional requirements are behavior that the system needs to have, and those are verifiable, meaning the customer themselves can test function number one, function number two, and see if the behavior is what they expected. Those are known as functional requirements. This is their needs of their customer, and customer can easily verify it. Non-functional requirement really is your the software engineer requirement. What I mean by that is the customer can ask you to make sure the system is up and running 99% of the time. Okay, that 99.9% of the time is not any function of the system. It is just the system has to be available for anyone that want to use it, be able to use it. Think of it this way. In your cell phone, if one of the functional requirements is to be able to dial people, then the non-functional requirement would be that your phone should be turned on whenever you want to turn it on. Because if your phone is not able to turn on, then there's no way you can perform texting, calling, browsing the internet, all of those other functional stuff. So the non-functional requirement here would be the system has to be available for 99.9% of the time. Also, the speed of the system. The system has to be fast. The system has to respond within a couple of milliseconds, right? Those are, once again, they don't deal with any specific functional requirement. They are more dealing with just the what's the word? The supplemental, right? Like if you use your phone once again and you play video games, then you don't expect any lag, right? But lag is not it's not something that can be verified. Something that can be verified is if a gamer clear level one, they should be rewarded with $2 million, $3 million, new weapons, new skill, things like that are functional requirement. Non-functional requirement are the characteristic that help make people want to use your system, right? So once again, non-functional are things that really the customer cannot see or feel. Functional requirements are things that the customer can actually verify themselves. System characteristics such as fast response time, always on 99.9% of the time, things like that, right? Now, after you have your requirement already, the next things in the process is the system design specification. Okay, in the system design specification, what is important? The system design specification, you need to know what non-functional requirement is needed. The non-functional requirement ultimately is what will be turned into the high-level system architecture. What do I mean by that? Okay, so let's just talk about this more. Let's say one of the non-functional requirement is the pizza sub must be must respond to user click within 1 millisecond. Okay, all right. So now most of the system usually have a front end or a GUI. Right? Assume this is your customer and they are using your pizza sub, so they would have a front end. The front end usually is then connect to a backend. Okay, the backend would have some logic, but ultimately it will be connected to a database, right? So just imagine you have one customer. This customer is using this system, and because there's only one customer using this system right now, all of the resources of the front end, backend, and database is being reserved to serve this customer. But what happens when you have multiple customers using the system? Customer number one, customer number two, customer number three, and so on. Okay, so now because all three of these they are using the system at the same time, arguably it will be slow for some people. Just like in a video game, if you have just 10 players on the server versus having 3 million players on the same server, the server will be slow, right? So if one of the characteristics of the system is it must be fast, then this will contribute to your high level system design. And by that, I mean a lot of the strategy that people would use is they might create another database. And those two databases, right, will run simultaneously. You have database one and you also have database two. They run once again simultaneously. Doesn't matter what runs first, what runs second. The whole point is we want both of them to run just so that both databases can be used to support these customers. The both way data synchronization. Okay, so now what does this mean? It means now if customer one place an order, right, then the transaction will be processed by database one. But if customer two place the same order, then the transaction will be served by database two. Let's just say this is database two and this is database one. Okay. Now if customer three also place the same order, then the transaction will be route robin between database one and database two. Whatever database is free and don't handle any transaction at the moment. So already with just this requirement, it's already forcing the developers or the system architect to know that you need to have, for lack of a better word, a load balancer or multiple instances of front end, multiple instances of back end, multiple instances of the database, just so that it can split the workload coming into the system. And this will allow the system to be able to support multiple users at the same time without any lag, right? So this is, and notice how I haven't specifically say how the backend should be designed and developed, how the front end should be. I simply show you the high level architecture of the majority of system nowadays, front end, back end database. And I explain that in order to accomplish this non-functional requirement, your system architecture needs to at least have two databases, for example, just so that it can split the workload, right? So this is an example of how non-functional requirement will contribute to high-level system architecture. And vice versa, your functional requirement here will contribute to the low-level system architecture. Don't complicate these, right? Just think of low-level system architecture is really all the class diagram. Hey, how are you going to design this class? How is this class going to talk to another class? Those things you can look more into what is known as collaboration diagram or sequence diagram, right? Also look into class diagram. I have some video that I recorded a couple semesters back that you guys can watch. It will teach you how to create sequence diagram and collaboration diagram. So, but those diagrams really is your low-level system architecture. Okay, so we just covered for software into the software development. You will learn all this process. First, the requirement, and within the requirement, right? The most important thing is first know who your customer is, what it is that they want, what it is that your system needs to behave. From knowing these, you can then build a requirement specification consisting of the functional requirement and the non-functional requirement. After you have the requirement, you can then move on to the system design specification, right? System design specification is really just high-level system architecture and low-level system architecture. Once you have both of these already, the next thing is implementation, which is coding. And for coding, it's really just you coding the low-level system architecture. The high-level system architecture is just creating more copy of your system. And usually that high-level system architecture will be handled a lot of time nowadays by the data pipeline, the development pipeline that most companies have, but we will talk more about it in system design class or software architecture class. But implementation really is just coding, right? After you done the coding, the most obvious thing is testing. For this testing, really you need to know what it is that you need to test. You need to have a test plan, and usually the test plan is just looking at both the non-functional and the functional. And then for each of those requirements, literally have task of how to test those requirements. Okay. And after the testing is done, then it's really production deployment or release, right? But we're not gonna do that. So let's just say right, this is where you hand over the system to the customer, right? So the step in software development is really requirement specification, system design specification, implementation, testing, and production deployment. All right. Now let's talk about your project a little bit. So this is a piece of project art. Doesn't look very good. Let me copy and move it here so you guys can see it better. Okay, so I'm not gonna go over all of these, but let's just go over some of the requirements. Okay, so your pizza system will have customer. Your pizza system need to be able to process payment. Your pizza system should record the customer transaction, so it need to have a database. Your pizza system need to be able to print out receipt. Your pizza system should have the restaurant menu, which is a GUI. Okay, so now you guys should be working on the project plan already, which I provided the example. If you guys have any questions, just email me. But the next thing after the project plan is the requirement document. And don't follow these. Okay, whatever it say here, you can ignore it because asking for class diagram and class documentation in a requirement document is just wrong. These belong in system design specification, not class diagram. I will provide an example from previous semester in my actual software requirement class for you guys to follow. But in your requirement document, I minimally want to have the following. It should have use case diagram. Use case diagram means for each of your functional requirement, and I only want the functional requirement. For each of your functional requirement, you should have a diagram illustrate how that use case work out. For example, the customer should be able to place order via the menu. Okay, what happens if they are placing order and then they want to cancel? How are they going to cancel? Right, so your use case to talk to each of the of how the system is going to be used, and then from there expand on, hey, if they want to order and they successfully select all their pizza, they should be able to submit and place an order. If they order at the end, they change their mind, they want to cancel, they should be able to cancel. Okay, you can ignore class diagram and class documentation. Don't worry about these, and it's safe to use join to idea. So whatever you're comfortable with. My favorite tool is Lucid, and the free version for it is really Draw.io. I am a huge fan of Draw.io, and I would highly recommend it. I will send you guys some video too, so that you guys know how to use Draw.io. Okay, ER diagram. So this ER diagram, let's talk more about it. Entity relationship. This actually is quite straightforward. Let's do an example. What it is that your system must have. So let's go back to the requirement. Sorry, wrong one. Okay, in the requirement, okay, you will have customer. Okay, so let's write it down. You need customer. All right. And then what it is that you need payment. Okay, so let's write out payment. Okay, what else do you need? You need a database. Okay, so you can store customer data. You need to print out receipt. Okay, that's fine. So database, receipt, okay, and GUI so they can place order. Okay, so you need to have a GUI. All right. How are you going to build out an entity relationship diagram? Okay, so see, entity relationship diagram. Now, first thing is just draw a box like this and say pizza system, right? Each of the requirement or each of these things here would be an entity. So you would have a context that say GUI. You have another one that say payment system. You have another one that say GUI or order menu. And if you guys don't know what GUI stands for, it stands for graphical user interface, which just means just a UI. For example, we go into Papa John. Where do I even order? Okay, start my order. Okay, so see, when I start my order, it's asking for all of these. I have to fill out, and I guess I'll be able to select my pizza how I want it. And I actually order with Johnny, so we can use this. Yeah, whatever. Yeah, yeah. I'm not gonna order though. I'm just showing you guys an example. So these are all the GUI here. Okay, I can select this. I can view my own. I can select these extra cheese, no cheese, extra pepperoni, Hawaiian, extra pineapple, things like that. I can add to order. So that's a GUI, right? So you need to have a GUI. Makes sense, right? And then next is need to be able to print receipt or show receipt, print receipt, and finally you need to have a database just to persist what the customer actually ordered, their address, so that if they order again, you can easily look them up. That this is what I want for an ER diagram. I don't want anything fancy, right? This remember this ER diagram. Think of it as a context diagram. Don't make things complicated. This pizza system need to have these high level requirements. You need to have payment capability. Need to have a GUI so customer can order. Need to have a database. Need to be able to print receipt, right? And so these would be your ER. And then I just attach this to your requirement document, and that will be enough for me. I don't really care about anyone else. I'm the instructor. So if you meet my requirement, that's really what matters. And plus, in the industry nowadays, really just having this as a context diagram will stand you out by a lot. Okay, so that's all I want for your requirement documentation, right? In the requirement documentation, I will send you guys an example, and based on the what the school is required you to have, which is the definition, like which when you guys read through this description, you need to come up with a functional and non-functional yourself. I'm telling you right now, on the non-functional, I at least want you to have the system to respond fast. But if it's too slow, customer will leave and no one will want to place orders. So every mouse click is respond within 2 milliseconds. Another non-functional requirement is the system must be available 99.9% of the time. And so just take those two as your non-functional and just work on the rest of these. You can ignore flash diagrams, don't need flash diagrams. Entity relationship, just give me a context diagram like what I just showed you earlier, and that would be enough. The season table, you can look into it. This will be helpful for you to know. So just look into it. Not much to really talk about here. All right. So I will send you a actual SRS document that previous semester did so you guys can see, but hopefully this video helped clear up a couple of things for you and introduce you to Jordan IO as well. I will send you my YouTube channel There is a lot of useful video there that you guys can watch. And I did receive a lot of the resume from y'all, so thank you. Thank you for trusting me to review your resume. It will take some time for me to get back to you simply because there's a lot a lot of you guys that email me, but I promise you I will review all and send you back my recommendation. All right, so that's all. Hopefully this helped, and if you guys have any question, just email me. All right, thank you.